Hello, welcome to this lesson of our study of partial differentiation. Okay, so in this lesson, we'll just go through what I mean by the implicit partial differentiation. Okay, so if you have not subscribed to the channel, kindly subscribe to support the channel as well. Okay, all right, let's start. So you're supposed to find the del z del x. Okay, this is the equation given yz. Okay, this equation yz minus ln of z equals x plus y defines z. This is very important. Z as a function of the two independent variable x and y, and the partial derivatives exist. Okay, so what this simply means is that you should know that z is a function of both x and y. Okay, and now is inside the equation. I'm supposed to find del z del x. The only way we can do this is using implicit differentiation. Okay, the idea that we have in implicit differentiation. Okay, so let's start. Now, like I said, we are supposed to note that this is a function of both x and y, and our task here is to find del z del x, and this is the equation given. Okay, so in order to do that, apart from z and x, any variable present should be considered as a constant. Okay, so first of all, we have to differentiate them term wise. Okay, del z of yz minus del x of ln of z should be equal to del x of x plus del x of y. Okay, so now with this one, since y is a constant, I can pull it out and be like this: y out del z, or del x of z minus del x of ln of z should be equal to 1, because when I differentiate x with respect to x, I get 1, then plus 0. Okay, now if you remember, you said that z is a function of x. Okay, so if I'm to differentiate z, it's like I'm using a chain rule, a function inside another function. So you want to differentiate something inside z with respect to x, but z is also a function of x. So first of all, what you will do is you differentiate z. Okay, like we know in chain rule, and we'll get what? 1. Then we'll differentiate the function inside z as a function of x. So we'll differentiate it like this, and that is what we don't know. Okay, so this is how it goes about. So minus this one too, we differentiate the ln here, okay, of z. That will give me what? 1 over z. Then I differentiate the z inside the ln, okay, with respect to s, since z is a function of x. Okay, then equal to 1. I hope this is okay. So what we get here is we get something like this: y del z del x, okay, minus 1 over z del x should be equal to 1. Okay, so simply I factor y minus, sorry, I factor del z del x out from both terms, then equal to 1, like that. Okay, so if I simplify the fraction here, I'll get yz minus 1 over z, okay, then del z del x should be equal to 1. Now with this, del z del x here should be equal to 1 over the whole of this expression, yz minus 1 over z. Okay, so if I simplify the fraction very nicely, I'll get del z here, del x should be equal to z over yz minus 1. Okay, this is very simple like that. Okay, so using the idea of implicit differentiation, this is what we've gotten for del z del x. Now let's move on to the next question. The next question is saying that find the value. Okay, you're supposed to find the value of del z del x at. So here, not only should we find del z del x, but you are supposed to simplify it at a point 1 1 1. If the equation, now there is a different equation given here, like this. If the equation xy plus z squared x minus 2yz equals 0 defines z as a function of two independent variables x and y, and the partial derivative exists. Okay, so fast forward, what you do is you do like what we did. Okay, so z is a function of both x and y, and this is the equation, and our task is to simplify del z del x at the point 1 1 1. Okay, so now to start with, first of all, what you do is, like I said, you differentiate them term wise. Okay, xy, then plus z cube, sorry, del x should come, del x of z cube x, then minus del x of 2yz, okay, should be equal to 0. Now if I differentiate 0, I'll get 0. That's why I didn't write anything there. Okay, so now with this one, what you can do is, first of all, y is constant apart from x and z. Okay, since z is a function of both x and y, that is why we don't treat it as a constant. Okay, so what we do here is we factor on our constant out, then y out del x of x, then plus. Now with this, since z is a function of x and it's multiplying another function of x, which is x, here we have two functions here. We have z cube. Z is a function of x. I hope you get what I'm trying to do. Z is a function of x here. Okay, so that is one function, and we have x, which is also a function of x. X is a function of x. I hope we understand this. So what you can do here is, since you have two product of two functions, you apply your product rule to this one. Okay, so first of all, we keep x. Okay, we can keep x, then we differentiate the z cube with respect to x, then plus we keep the z cube, then we differentiate the x with respect to x. I hope you get this. Now minus, since y is a 2y is a constant, I can factor that one out, and del x of z, since z is a function of x. I hope you get this. So if I differentiate every term, okay, if I differentiate every term, the first term, if I differentiate, I'll get just y. Okay, so I get y plus, the second one, you are differentiating x times differential of z cube with respect to s, and z is a function of s, so I have to differentiate the z cube first, and I'll get what, 3 z squared, right? Then x, then I differentiate the z itself with respect to x, and I'll get del z del x. Okay, so with this, then I'll move forward to the other one, plus z cube times the differential of x with respect to s, and that will be just 1, so z cube times 1, then minus 2y, and differentiate z. If you remember, this is what you have, differentiate z with respect to s, so I have to just differentiate z, I'll get 1, with respect to z I'll get 1, then I differentiate the z itself with respect to s, I'll get del z, is it del, no, there's no plus here, del z del x should be equal to 0. Okay, so very simple like that. I have to just simplify it further, then plus 3z squared x, or you can put x first, sorry, del z del x here, then plus z cube minus 2y del z del x should be equal to 0. Okay, so I can send those terms standing alone to the right side of the equation, and I'll get something like 3z squared x del z del x minus 2yz del z del x should be equal to negative y negative z cube. Okay, now with this, what we can do is we can divide through by negative, okay, so that we get something like 2y del z del x here minus 3xz squared. Let me put it this way, okay, del z del x. I hope you can see what I've written here. I just wanted our right side to be positive, okay, z cube, okay, like this. I hope this is very cool. Alright, so with this, I can simply factor my del z del x out, so I'll get 2y minus 3x z squared out, and del z del x should be equal to y plus z cube. Okay, so making del z del x the subject, simply we have del z del x being equal to y plus z cube all over 2y minus 3x z squared. Okay, so this is my del z del s, but we are supposed to simplify this at the point 1 1 1. Each of the variables is 1. Okay, so del z del x at this point will be equal to 1 plus 1 cube over 2 into 1 minus 3 into 1 times 1 squared, and this is equal to 2 over 2 minus 3, so this will give me negative 2. Okay, so I hope you understand this. So this is a solution to the question that we were solving. Thank you, and don't forget to subscribe to my channel to support it.